Okay, so today we will talk about the quiz 2 review list. Okay, so the beginning part is the graph of quadratic functions, right? Quadratic functions. So first function, f of x is -3 x minus 1 squared plus 2. Okay, plus 2. So this is the easier case. So the vertex is given in this expression. Okay, in this expression. So now let's write down the formula for this. F of x is a x minus h squared plus k. Okay, plus k. So the quadratic function is given in this form. Then we got the vertex is hk. So in this example, h is 1, k is 2. So vertex is 1, 2, right? 1, 2. So h is 1, k is 2. So now what is the a here? A is -3, right? A is -3. Okay, so now we know the vertex is 1, 2. So what's a did? A will tell us the parabola is open up or open down, right? So if a is bigger than 0, so we will have a parabola open up. Here is the vertex, the minimum. If a is less than 0, we will have a vertex open down. It's like an M, and then the vertex, it will be the top. Okay, it will be the top. So now a is -3. So we have the second case, right? We have the second case. So now let's draw the graph. So we know vertex is 1, 2. So here is 1, 2. 1, 1, 2. So V is here, 1, 2. And then from A is negative, we know it's open down. So we got this picture. Okay, we got this picture. Okay, and sometimes we also label this y-intercept, right? Y-intercept. So what's y-intercept of this example is 0, f of 0. So this is 0, f of 0, you plug in 0, right? You plug in 0, then you got -1, okay, -1. So this is f of 0 is -3, 0 minus 1 squared plus 2. So this is -3 plus 2, which is -1. Okay, that's our first example. Okay, first example. So you have to know this formula, right? You have to know this formula. It's a times x minus h squared plus k. Okay, you can call this the vertex form of quadratic function. So because it's given hk, the vertex. Okay, vertex. Okay, so now that's the first case. Second case, you are given the standard form of quadratic function. So number 2, f of x is 2x squared minus 8x plus 5, right? So now the corresponding formula, f of x is capital AX squared plus capital BX plus C, right? Plus C. Okay, so now we got A is 2, B is -8, and then C is 5. So now for this case, you have to use a special formula to calculate the vertex, right? So vertex is h, so this is -b over 2a, and then what is k? K is f of h. Okay, f of h. So it's very easy to find h, and then you plug in h to find k, right? To find k. So now here h is -b, b is -8 over 2a, so it's 2 times 2. Then we got number 2. Okay, so k is f of h, so k is f of 2. Then you plug in 2, replace x by 2 here. Then we got 2 times 2 squared minus 8 times 2 plus 5. Okay, plus 5. This is 8 minus 16 plus 5, -3. Okay, -3. So we got the vertex is 2, -3, right? So this is hk. And then A is positive, so we got a U shape. Here is the vertex, right? Here is the vertex. So now given in this stand form, the y-intercept is easier. Y-intercept is just 0 of f dot 0, which is 0c for this standard form. Okay, the first one I call it vertex form. This one is called standard form. Okay, standard form give you ABC. So for quadratic formula, it's also based on this standard form, right? Standard form. Okay, so now let's draw the graph. So is 2, -3. So here is the vertex V, and then the 0c, c is 5, so this is 0, 5, right? 0, 5. So we got a y-intercept here, right? So now let's draw a parabola. Pass the triangle, y-intercept, go down to the vertex, and then turn up at the vertex. That's the parabola. Okay, that's the parabola. So that is the first part of the graph for parabola. For degree 2 function, we just use vertex, and then A tells you is open up or open down. Okay, open down. So now for degree 3 polynomial, we have to use synthetic division, right? So that's why we will talk about synthetic division now. We'll find x1, use synthetic division, and then for the qx is quadratic, we can find 2 more solutions, and then we draw the graph, right? And then we draw the graph. Okay, so now for the synthetic division. So I'm going to do the first one, and then talk about the important things of the second example, and then leave the second example to you as exercise, right? Okay, so now the first one is 3x cubed minus 5x squared plus 3x minus 1 divided by x minus 2. So we want to find the qx, and then we want to find the remainder r, right? The remainder r. Okay, yeah. So now set up for the synthetic division. So for all these coefficients, they are the top line, right? They are the top line of synthetic division. So we got 3, -5, 3, -1, right? -1. And then the divisor is x minus c. Okay, so this is very important. Divisor is x minus c. Right? Divisor we use dx. So the dividend we use f of x. So x minus c is x minus 2. So c is 2. Okay, c is 2. And then if the remainder is 0, we got a solution, right? For the f, x1. If remainder is not 0, then we continue, right? Then we continue. Okay, so now let's find the remainder first. So step 1, we bring down 3. Okay, so you can also think this is addition. 3 plus nothing is 3, right? 3. And then we multiply, move it back, right? So here is 3 times 2. Then we got 6. And then we add, moving down. So 6 plus -5, 1. And then multiply, we go back. 1 times 2, 2. 3 plus 2, we got 5 again, right? 5 again. And then 5 times 2, multiply, we go back, we got 10. And then -1 plus 10, we got remainder 9. Okay, remainder 9. So now we got the remainder part for this division, right? Quotient always has, the division always has 2 solutions, 2 parts of the solutions, quotient and remainder, right? Quotient and remainder. So now the last number is the remainder. So these 3 numbers will give us the quotient q of x, right? So q of x is 3x squared plus 1x plus 5. Okay, yeah, so these 3 numbers, they are the coefficient in the decreasing order for the quotient q. Okay, for the quotient q. So this is the first synthetic division. Okay, synthetic division. So now the second example, 5x cubed plus 4x squared minus 3 divided by x plus 1. So I'm not going to do this whole synthetic division. So first you have to be careful. C is -1, right? So x minus c is x plus 1. So c is -1. C is not 1. Okay, c is not 1. And then the important thing is we are not having 3 numbers in this synthetic division in this top line. So 5, 4, -3, and then there is a missing linear term, right? Missing linear term. So what's the missing linear term? 0x. Okay, so there is a 0 here. Okay, that's how we start synthetic division. Okay, and then you move down, add, multiply, add, multiply, add, multiply, add. You got the remainder and the quotient, right? The quotient. So I will just tell you the answer. Okay, I will just tell you the answer. It's a practice. So r is -4, and then the quotient is 5x squared minus x plus 1. Okay, plus 1. So this is an easy exercise. Okay, easy exercise. Okay, yeah. So this is equal to qx with remainder, right? With remainder. Okay, yeah. So now after we got this, after we know the synthetic division, we can find 3 zeros for degree 3 polynomial. Okay, for degree 3 polynomial. So again, I'm going to solve the first one, and then the second one is the exercise. I will write down all the solutions. Okay, solutions. Okay, so now what's the first one? The first one, f of x is x cubed plus x squared minus 4x minus 4. Okay, minus 4. Okay, so now step 1, we list all the possible c's, right? Okay, so c is factors of last number divided by factors of first number in the given f, right? Given f. So this is factors of 4. The last number is 4. Positive or negative doesn't matter. Okay, divided by factors of 1. Okay, yeah, 1 is the leading coefficient here, 1x cubed, right? 1x cubed. Then we got positive -4, positive -2, positive -1, divided by positive -1. So what are my possible c's? So we got positive -1, positive -2, positive -4. So these 6 possible c's. That's step 1. And then step 2 is the synthetic division until we find, for all these c's, until we find the remainder 0. Okay, remainder 0. Division to find a remainder 0. Okay, for all these 6 c's, right? 6 c's. Okay, so now let's look at the first one. C is 1, right? C is 1. Okay, so C is 1. What do we got? We got 1, 1, -4, -4. So you bring down 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. -4 plus 2 is -2. And then 1 times -2, -2. And then you got -6. This is the remainder. So now the remainder is not 0. We need remainder 0, right? Remainder is not 0, so that's not our first solution. Okay, so we are trying to find 3 solutions, x1, x2, and x3. So step 2 will give us the first solution. So c is equal to 1, doesn't work. We go to the next one. C is equal to -1, right? -1. So c is -1, then what do we got? The same f, so we got the same top line here for the synthetic division. -4, -4, right? So bring down 1. 1 times 1, 1, 1 plus 1, 2. Oh, sorry, here's -1, right? So 1 times -1, this is -1. 1 plus -1, this is 0, right? This is 0. Okay? Yeah. And 0 times -1 is 0. -4 plus 0, -4. -1 times -4, we got 4. 4 plus -4, we got remainder 0. Okay, remainder 0. So that's our first solution. Now we got our first solution. C is x -1, so this is will be x1 is -1. So now what is our quotient, right? We have remainder 0. We also need quotient for division, for synthetic division. So quotient Q of x is from these 3 numbers down here. This will be 1x squared plus 0x minus 4, which is x squared minus 4. Okay, x squared minus 4. Okay, yeah, so that is our step 2, right? That is our step 2. Okay, and then sometimes we also use multiplication to write down f of x, right? So if remainder is 0, that implies f of x is dx times qx. So what is dx? dx is x minus c, right? X minus c. So c is -1 for this case. So this is x minus -1 times x squared minus 4. So f of x is x plus 1. x squared minus 4. Okay, so we can also factor f of x using this step 2, using remainder 0 for synthetic division. Okay, for synthetic division. Okay, so now let's continue to find x2, x3. Okay, x2, x3. And then I'm going to talk about 3 methods to solve x2, x3. So step 3, we focus on q of x, right? So q of x now we know is x squared minus 4. So what's solution 1? What's solution A? Solution A, we use factoring. Okay, we use factoring. So x squared minus 4 can be factored as x plus 2, x minus 2. You can think this is the triangular method. You can think this is special formula. It doesn't matter. And then we let this equal to 0, that equal to 0 to find the other 2 solutions. So x plus 2 is 0. We got x2 is negative 2. X minus 2 is 0. We got x3 is 2. Right? It's 2. So that's the first method to find x2, x3. So now method B to find x2, x3 is the quadratic formula. Okay, is the quadratic formula. So we know x squared minus 4 is 0. Then A is 1. B is 0, C is negative 4. Then you use quadratic formula. So x is negative b plus minus square root of b squared minus 4ac divided by 2a. So you will get 2 more solutions, positive negative 2. Okay, so x2 is negative 2, x3 is 2. Same solutions. Okay, same solutions. Okay, so here we don't want to draw the graph. We don't need to cut the x-axis. We just find 3 solutions. Okay, 3 solutions. So now what's the last method for the q, right? What's the last method for q? We use synthetic division for q. Okay, we repeat step 1 and 2 until we got remainder 0. Then we got 2 more solutions. Okay, 2 more solutions. Okay, yeah. So now q of x is x squared minus 4. So step 1, possible c. So we got the same set of possible c. Positive negative 1, positive negative 2, positive negative 4. Okay? Now I'm going to jump to c equals 2 because I know c equals 2 will give you a remainder 0. Okay? So you can check c is 1, negative 1 doesn't work. Okay? Doesn't work. Okay? So because I don't have enough space, right? Enough space. So c is 2. So now what's q? The top line from q is 1, 0, negative 4, right? There's no x term, so there's a 0x. So we have 3 numbers for degree 2q for synthetic division. So bring down 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. And then we got remainder 0. Okay, remainder 0. Then we get 1 more solution, right? 1 more solution. So now this will be our x2 is 2. So now where can we get x3? This new q of x. Right, the new quotient. So let's call this q star of x. So this will be x plus 2. So this is equal to 0. Then we got x3 is negative 2. Okay, negative 2. Okay, so that's the third solution, third way to find x2, x3. The order doesn't matter. Okay, anyway, they are the 2 numbers, 2 and negative 2. Okay, 2 and negative 2. So now we have 3 solutions, right? So first solution, negative 1. And then we get 2 and negative 2 for the other 2. Okay, for the other 2 solutions. Okay, yeah. So now for the second problem, f of x is 2x cubed plus x squared minus 2x minus 1. So I will just write down the key steps, right? Key steps. So possible c's are positive negative 1 and positive negative 1/2. Okay, and then which one will give you remainder 0? So c equals to 1 can give you remainder 0. And then you got q of x is 2x squared plus 3x plus 1. So now you can use factoring, quadratic formula, or synthetic division for q. You can get 2 more solutions. Okay, x2 is negative 1/2. x3 is negative 1. Okay, so we got 3 solutions for degree 3 polynomial. Okay, for degree 3 polynomial. So that is the second part, right? The second part. Find 3 zeros, right? Find 3 zeros. Okay, so now let's look at the inequality question. So the inequality question is after we factor the f, right? After we factor the f, and then mainly we just cut the x-axis, right? Okay, so now we got two solutions from linear factors. So x plus 3 is 0, we got x1 is negative 3. X plus 6 is 0, we got x2 is negative 6, right? Negative 6. Then we got two zeros, so negative 6, negative 3, right? Negative 3. And then we look at this non-zero side as a function f, right? We look at f of 10 is positive or negative, so that gives us the sign on the most right, right? Most right. So f of 10 will be 10 plus 3, 13, times 10 plus 6, 16, so it's positive, so the first sign is positive, right? And then we have two rules, right? So for linear factor, for linear 0, we always change the sign, change positive to negative or change negative to positive. And then for double factors, because we change and then change again at the same number, so we keep it, right? So positive change to negative, and then we change it again back to positive, so we keep the sign, right? We keep the sign. But they are all linear, right? They are all linear factors, linear zeros here, negative 3, negative 6, so we change, right? So first sign is positive, then we got negative, and then we got positive. Just keep switch, right? Keep switch. So now for this question, they want less than 0, right? Less than 0 means they want negative sign. Negative sign. So the solution is from negative 6 to negative 3. Okay, negative 3. So this is an easy topic, okay? Easy topic. Okay, but it's the next step for the graph, right? After you solve 3 zeros, we need this kind of partition of x-axis, and then we got the graph, right? The graph. Okay, so now the next inequality. So now again, here is x minus 1, x plus 5, x minus 2. So we want this time greater or equal to than 0, right? So this time means this one we want positive sign, right? We want positive sign. So we got x1 is 1, so that is equal to 0. X plus 5 is 0, so x2 is negative 5. X minus 2 is 0, we got x3 is 2. Okay, is 2. So now for the numerator, we use triangle. For denominator, we use the dot line, right, to cut it. It's just two different notations, right? Two different notations. Okay, so we got negative 5 is a triangle, 1 is a triangle, and then 2 is a dot line, right? That's how we cut. And then we look at f of 10. You plug in 10, right? 10 minus 1, 10 plus 5, divided by 10 minus 2. So this is positive, right? 9, 15, 8, nothing negative. So this is positive. So here is 2, right? I forgot to write on the 2. Okay? Yeah. So now this is positive. So now we switch for linear factors. They are all linear, right? So this is negative, positive, and then negative. And the solutions are positive part. So we get two solutions from negative 5 to 1, and from 2 to positive infinity. Okay, positive infinity. So because this is an equal sign, right? So can equal to 0. So triangles included, but this dot line makes denominator 0. So for fractions, denominator is 0. So we have to change it to open, right? We have to change it to open. Okay, yeah, so that's the inequality. You just cut, label the first sign, and then switch, right? Except there's a double 0, okay, double 0. Okay, yeah, so now let's go to the graph part. And again, for the graph part, because it's too similar to the 3 zeros question, so I'm going to do it a little bit faster, okay, do it a little faster. So we got f of x is negative x cubed plus 3x squared plus x minus 3, right? Minus 3. Okay, so first we list out possible c's. So this is positive negative 3, positive negative 1, divided by positive negative 1. Factors of last divided by factors of first. then we got positive, -1, positive, -3, right? So we have 4 possible C's. Okay, and then for all these C's, we do the synthetic division until remainder 0, right? Until remainder 0. Okay, yeah. And this time we try C is 1, then we got remainder 0, the first one. So it's -1, 3, 1, -3. This is -1, -1 times 1. Then we got -1, 3 plus -1, we got 2. 1 times 2, we got 3. 1 plus 2, we got 3. 1 times 2, we got 2. And 1 plus 2, we got 3. 1 times 3, we got 3. And then remainder is 0, right? Remainder is 0. So we got our first solution. X1 is 1. And then this is give us Qx, right? Give us Qx. So Q of x is negative x squared plus 2x plus 3. Okay, plus 3. So now we just factor to find the other two solutions. Okay? So this is x negative x plus 3, and then x plus 1. So this is equal to 0. Negative x plus 3 is 0. Give us x is 3, so that's our x2. And then x plus 1 is 0. Give us x3 is -1. Okay, -1. Then we get 2 more solutions, right? 2 more solutions. Okay, so now we get 3 solutions. Okay, 3 solutions, -1, +1, and then 3. Okay, and then 3. So now let's draw the graph. So this is our x-axis, and then we got -1, +1, and then 3. So what is our f? Our f of x is negative x cubed plus 3x squared plus x minus 3, right? Minus 3. Okay, so now again, we look at the first sign here, right? F of 10, just like inequality. Right, so this will be -1000 plus 300 plus 10 minus 3, so this is negative. Okay, and then we switch the sign because they're all linear, right? These zeros are all linear, no repeating 0, right? No repeating 0. Okay, yeah, so now negative sign means our graph start from lower half plane, right? So now let's just change to green color. Okay, so graph start from lower, reach triangle. Triangle, you have to pass the triangle. Go to upper half plane, go to lower half plane for negative sign, go to upper half plane for positive sign. Okay, yeah, that's the only new thing. Okay, only new thing. So plus sign means the graph is in the upper half plane, and minus sign means the graph is in the lower half plane. So that's the graph of f of x. Okay, graph of f of x. So it's very similar to the inequality, right? Very similar to the inequality for degree 3 polynomial. Okay, so now for the rational expression, rational function, it's a little bit harder. Okay, it's a little bit harder. So we got 2 minus x, and then x minus 1, x plus 1. Okay, yeah. So for this one, it's already factored, right? It's already factored. So we need the zeros of the top, zeros of the bottom to cut the x-axis. So 0 up top, 2 minus x is 0. Then we got x1 is 2. So this will be a triangle, right? And then these two in the denominator. So this is equal to 0, this is equal to 0. So x minus 1 is 0. We got x2 is 1. X plus 1 is 0. We got x3 is -1. Okay, so they are the dot lines because they're in the denominator, right? They're in the denominator. Okay, so now let's cut x-axis. So we got a -1 here. And then we got another dot line 1 here. And then we got a triangle at number 2, right? Triangle at number 2. So now we test f of 10 again, right? F of 10 again, not 0, f of 10. So this is 2 minus 10, 10 minus 1, and the 10 plus 1. So this is -8, 9, and 11. So this is negative, right? Negative. So the first sign is negative. And then we have these 3 cutting point on the x-axis. They're all linear, no repeating. So we got switch the sign, right? Switch the sign. Okay, yeah. So now let's again use green color to draw the graph. So negative sign means lower half plane. So we start from here. You pass triangles. You go to upper half plane, but you never cross this dot line. Dot line is the wall of the graph. Okay, they cut this plane to 3 parts. Never cross. Okay, never go to the other side of the wall. Okay, the other side of the wall. So that's the first branch of the graph. Okay, yeah, stop at number 1. So now for this middle negative sign, that tells us we have everything in the lower half plane, right? So it's suppose you start from here and then go to the wall. So there's no way you have to go down, right? You cannot go up to the positive side. So you can just keep going down, and then bounded by these 2 walls at negative 1 and 1. Okay, negative 1 and 1. So now for the last positive sign, that means we are in the upper half plane. So we go up to the wall, negative 1, right? Negative 1. So let's make this a little longer. Okay, yeah. So the graph of rational equations is harder. So it's not one curve, it's separated. It has 3 parts, 3 different curves. Okay, 3 different curves. Okay, so now what's the xy intercept and what's the vertical asymptotes? So that is vertical asymptotes are these dot lines, right? So 1, negative 1, so they are the vertical asymptotes. X-intercept is triangles, right? So x-intercept is x equals to 2. Vertical asymptotes, we have 2. x2 is 1 and x3 is negative 1. Okay, so what's y-intercept? Y-intercept is always 0, f of 0, right? F of 0. So this will be 0. So you plug in 0, you got 2 minus 0, 2. And then 0 minus 1, negative 1, 0 plus 1, 1. So it's 2, negative 2. So divided by 1 times negative 1, so is negative 2. Okay, so it's negative 2. So that's the y-intercept. So y-axis here. So we got this point, negative 2. That's the y-intercept. Okay, yeah. So there's also something called horizontal asymptotes. Right? Horizontal asymptotes, one understanding is you replace x by 1 million. You'll see is one number. Right? So here for this example, this will be 1 million over 1 million times 1 million. So it's 0. Right? So horizontal asymptote is 0. Okay? Yeah. So another understanding for the horizontal asymptotes is you use degrees. Right? Degrees, the largest the degrees. Okay? So the top degree 1, bottom degree 2, then the horizontal asymptotes will be 0. Okay, well, it's 0. We'll look at the largest degree. Okay, bottom one has 1. The top one, there's no degree 2, so it's 0. 0 over 1, 0. Okay, the largest degree of numerator and denominator. Okay, so that's horizontal asymptotes. Right, so this means y is equal to 0 is the horizontal asymptotes. Okay, yeah, that's it. That's our review video.